Okay. So before we get going on the notes for today, I want to take a moment to talk about this week. So I'm going to talk about this week in one of two ways. The first way is when things are rainbows and unicorns and it's 70 degrees and sunny outside. Okay? Alright? So today we're going to add the last step to our cheat sheet. So we're going to do step 6 today. And then we're going to do a couple of examples with it today. So there's 2 graphs today. Then tomorrow's Tuesday, we don't have class. Wednesday, we'll do some more examples, more graphing examples. Probably be one of those where we here's the graph, go graph it, give you 10, 15 minutes to graph it, then go over it, then do the next one same way, etc., etc., etc. Thursday, same format for Thursday. Friday, summative quiz. Okay, summative quiz this Friday, and then looking ahead to next week Thursday is testing. Okay? Right? So that's rainbows and unicorns. Okay? Now, impending weather coming in Tuesday night into Wednesday morning. Okay? They're talking lots of ice and blizzards and all that fun stuff. All the great parts of a good Wisconsin winter. Okay? Which would mean on a typical, pre-COVID school year would mean snow day. Okay? But now it means virtual learning day. Okay? So if that is the case and we do not have school on Wednesday, which is a possibility, if that is the case, there will be approximately a 20-minute video that you should watch on the Canvas. And it will have the examples that we would have done in class on Wednesday. Okay? And it'll be much the same way. I'll present it as, here's the example, pause the video, do the example, then play the video, and I go through the example. Okay? And there'll be 2 of those. Okay? So that's the plan right now. Any questions about that? Okay? If we do have a virtual learning day on Wednesday, your quiz will still be on Friday. Okay? That plan is still the same all the way through. It's just you'll have to watch the video. And then if on that Wednesday, if you have questions, just shoot me an email and I will open up a Google Meet and we can go in and we can get questions answered and all that fun stuff. Okay? All right. So with that being said, I've got stuff to hand back. Let me pause the video here and hand stuff back. So normally, when we're going through a function, first thing we do is we do step 0. It says so right on our sheet. We do step 0, factor the function, see if we can factor. Then after that, we look for the domain and any vertical asymptote. And then step 2 says we look for the horizontal asymptote. And if we have a horizontal asymptote, or to find a horizontal asymptote, if we're dealing with the small over big case, we're comparing degrees, then that's going to be y equals 0. We put a dashed line in, which is basically the x-axis, and we're all good. Or the second or the third case is if we're same over same. Then that one is y equals a over b. Now, one thing I did notice on the quizzes from this week, and it wasn't a lot of people, but it was more than I wanted. It's not the first number that you see on the top and the first number that you see on the bottom. It's the lead coefficient. So the numerator and the denominator need to be in standard form. Biggest exponent first, next, all the way down to the end. Okay? So make sure that you do that one. Okay?
But what I want to focus in on today is I want to focus in on that third characteristic when we have the big degree over the small degree. And normally, that would be a none case for horizontal asymptotes. Okay? But I'm going to tweak that a little bit, and that's going to develop for us step number 6. So the tweak that I have for you is that if the degree of the numerator is 1 bigger, then we have a slant asymptote. Okay? It's exactly what you would think it would be. A vertical asymptote is a vertical. It's up and down. A horizontal asymptote is left and right. A slant asymptote is a slant. Okay? It's not vertical, it's not horizontal, it's somewhere in between. Okay? If it's 1 degree higher, we'll find it. If it's 2 degrees higher, then it becomes a quadratic asymptote, and we're just not even going to deal with that. If it's 3 degrees higher, it's a cubic asymptote, and so on and so forth. Okay? So, how do we go about finding said slant asymptotes? Well, you're going to groan here a little bit, because to find the slant asymptote, we just have to do the division. So it becomes a dividing problem. Okay? Or a problem where, like we had in the last unit, where we can either synthetically divide it or we can long divide it. Okay? So in this particular case, let's go with x squared plus 4 over x minus 2 as our function. So I want to, first, can I factor the numerator? Yay or nay? Yay? What is it factored to be? What? Do we agree with x plus 2i? Do we want to go i's? Yeah, I would say we don't want to go i's, right? Because then now all of a sudden we can't graph it. Okay? So does the top factor? No, top doesn't factor at all. Okay? So we're good there. Okay? Bottom, does it factor? Nope, so we're good there. Okay, so step 0, done. Step 1, domain of this one would be what? All real numbers, but x can equal 2. Okay? Which means I have a vertical asymptote at x equals 2. Okay? So let's look at the horizontal asymptote now. On top, I've got a degree of 2. On the bottom, I've got a degree of 1. So that would normally say, in step number 2, that would say none for our horizontal asymptote. There wouldn't be a horizontal asymptote. But they differ by 1. Dice? I don't know what dice is. So they differ by 1, so there will be a slant asymptote. Okay? So, how we go about doing that? We have 2 options. The first thing is, we could do the division. Option number 1 says we can synthetically divide these 2 terms. Correct? Okay? So if I'm going to synthetically divide these 2 terms,
I would first set the divisor equal to 0, and I'd get x equals 2. So then I would do 2 on the outside, and coefficients 1, 0, and 4 on the inside. Drop it like it's hot. Multiply, add, multiply, add. So I'd be there. When I do that, I am going to drop any and all remainders. There will be a remainder. If there isn't a remainder, then you didn't do step 0 right, because it's a factor. So all of your slant asymptotes will have a remainder. And you literally just go through and forget about it. It's gone.
It doesn't matter.
Nope. It's so infinitesimal that it doesn't matter. Okay? Then what you're going to do is you're going to write your slant asymptote in the form of y equals mx plus b. Because you're going to differ by 1, which means your result is going to be linear. So down here, this slant asymptote would be y equals x plus 2. The other option that you have is you could do your old friend long division. And then you would drop that remainder. Okay? So either way, we get the same thing. So now we can fill in our step 6. We can fill in the finding the slant asymptote. Okay? So step 6 only happens if the numerator is 1 degree bigger than the denominator. How you go about doing it? First, you do the actual division. After you get done with the actual division, you drop the remainder. And that's going to leave you with a linear term. And so your slant asymptote would be y equals mx plus b. And so you graph that line then on your graph. You plot your y-intercept. You use your slope to get the next few points, and you draw it in dashed. Okay? It goes on the, like all of your other asymptotes. It goes on your graph with a dashed line. Give you you a couple of minutes to get that written down. A couple of seconds, actually, not much to write.
So let's do this one here. F of x equals x squared minus 3 all over x minus 2. Step 0 says, can I factor the top? Nope. Can I factor the bottom? Nope. Done. Step number 1 says, what is the domain? All real numbers. X cannot be 2. Second part of step 1, what is my vertical asymptote? X equals 2 goes on my graph. Vertically dashed, all good. Horizontal asymptote would be step number 2. The none case, because we're a 2 over a 1, right? But it differs by 1 degree. So I'm going to put a little asterisk there because that reminds me now step 6 comes into play. Okay. Side note, we're done with all of our steps now. So if you wanted to rewrite your supplemental sheet so that you have it all nice and pretty and readable and how you want it to be and on one side of a piece of paper, you can do that now. Okay?
Right now.
Not right now, but you can do that. Okay? Next up, we have our y-intercept. Where is our y-intercept?
Positive.
Positive 1/2?
Yes.
You know. What is our y-intercept? 3 over 2? Yep. Okay.
1/2.
You forgot the most important part of
Oh,
that.
I forgot the 1.
You forgot the and.
Oh.
Yeah, you just said 1/2. Yeah. Which is a different number than 3/2. Okay? Because 1 is not equal to 3. Huh? X-intercepts. Next, step 4. What you got? So square root of 3 comma 0 and negative square root of 3 comma 0. So that would be x squared minus 3 equals 0. So x squared equals 3. So x equals plus or minus square root of 3. Roughly how big is the square root of 3? .6, 1.7-ish. It's closer to 2 than it is to 1. So somewhere in that closer to 2, but not as close to 1 range there and range there. Okay. Do we have any holes?
No.
No, because we didn't cancel anything out. So
then that leaves us with slant asymptotes. So to find the slant asymptote, this is now step number 6. The first part of step 6 is we do the division. Do you want to do long division or synthetic division? Synthetic, okay? So if we're going to do this synthetically, I would say x minus 2 equals 0. So then x equals 2. So 2 is my outside number. My inside numbers are the coefficients 1, 0, and negative 3. Drop, multiply, add, multiply, add. Then I get rid of the remainder. And so my slant asymptote then would just be y equals 1x plus 2. Yes, ma'am. Because it's so infantilely small when we get to the extremes that it's not even worth it. Because it'd be hard to graph 2 on your graph with the remainder.
It'll also be like the number of your ads, so definitely get closer.
Okay? So how do I graph the y equals x plus 2?
We go line and set.
That doesn't help me.
You do the y-intercept first at positive 2,
Okay?
and then you go up 1, over 1.
I don't know over.
Rise over run.
Yeah.
So
I don't know the direction over. I never learned it in
So,
kindergarten.
it's
positive
right
one.
infinity.
So it's the right?
Yeah.
So up 1 and right 1?
Yeah.
Yeah.
Okay.
To the positive is
Back now, I went to kindergarten back in the 19s, okay? And back then we didn't know a direction for over.
See it.
Well, it's just over.
Over.
Yeah.
It's just over.
Out. When you figure out the direction,
I can't
you
do
go
that
like
while
this.
driving. So
Oh, I can't.
More.
You don't drive like this
No.
with your hands.
So then that's going to go on there dashed. Still have 2 zones, right? I've got a left zone and a right zone. Do I have enough points in the left zone?
Yeah.
I got 3 of them, right? Okay. But if I wanted to, I could add in 1. Right? If I wanted to make a T-chart for 1, if I plug in 1, I'd have 1 minus 3 is negative 2 over 1 minus 2 is negative 1. So that would be 2. So I would go through that point right there. So my graph in here will look like that. Right zone. Need lots of points, right? I would pick 3, 4, and 7. I don't need to pick 10 because 10 is going to be way off my graph. 9 is going to be off my graph. 8 is going to be off my graph. Okay? So let's pick 3, 4, and 7. If I plug 3 in there, 3 is going to be 9 minus 3 is 6. 3 minus 2 is 1, so that's going to be 6. 2, 4, and 6. If I put 16 minus 3 is 13. 4 minus 2 is 2. That's going to be 6.5. If I put in 7, 49 minus 3 is 46. 7 minus 2 is 5. 46 divided by 5 is 9.2. your graphs will finish along the slant asymptotes, just as they finish along the horizontal. Okay? Yes. You can cross over a slanted asymptote, but it would be in a middle of two vertical asymptotes type case. Okay. All right. Good questions about it. Do that one. You try this one, and then I'll come back and I'll do it. Numerator, does it factor? Yes. What does it factor to be? Denominator doesn't factor. So step 0 done. Okay. So then we can go on to step number 1. Step number 1 would say that we should find the domain and any and all vertical asymptotes. What is the domain of this function? This can't be 2 again, which means vertical asymptote is x equals 2. Goes on our graph. Vertically, 2. Okay. Horizontal asymptote. None, right? Degree of the top is 2. Degree of the bottom is 1. But none gets an asterisk because it differs by 1, which means step 6 is in play. Y-intercept is next. If I cross out all of the x's, so that term's gone, that term's gone, and that term's gone, the only thing I'm left with is 5 over negative 2. So that is negative 2.5. X-intercepts, I set the numerator, which luckily in step 0 I factored already. Set that equal to 0, which means then that x minus 1 would be 0. So x would be 1. X minus 5 would be 0. So x would be 5. So I'd have 2 again, 1 comma 0, and 5 comma 0. 2, 3, 4, and 5. Since I didn't factor anything out in step 0, there is no hole. Later on this week, we'll have everything. We'll have a couple examples with everything in it. Slant asymptotes, holes, all that fun stuff. And then we got step 6, finding our slant asymptote. So I take x minus 2, and I set it equal to 0, and that gives me x equals 2. So then I put 2 in 1, negative 6, and 5. So drop is 1, multiply is 2, add is negative 4, multiply is negative 8, add is negative 3, drop the remainder, makes the negative 3 go away. So my slant asymptote is y equals 1x minus 4. That would be a y-intercept of negative 4, a slope of 1, so that is to the right 1 and up 1, or to the left 1 and down 1. it also goes on dashed.
Left zone, do I have enough points? Got 2 of them. Right zone, probably could use a point or 2 yet in there. So let's go with 3. If I put in 3, I've got 9 minus 18, that's negative 9, plus 5 is negative 4, all over 1. Now we got enough. And there you go. Again, I remind you that you will have a summative quiz this week, Friday. Also, I remind you that if Wednesday is an inclement weather day, that you will have a video to watch on Canvas, and that video will be posted by 9 o'clock on Canvas, and then I will be available for questions via email and or setting up a Google Meet.
So we don't have to log into a Google Meet. Thank you.